Hello, everybody. I want to welcome all of you to this first webinar of 2024 from Altec. The main topic of today's webinar is to present how the current green trend of the industry will affect the synthetic graphite market. To review this, our presenter today is Fabrizio MASIA, which is the Director of European Business Development of Altec. Do not hesitate to interact using and ask your question using the web interface. Fabrizio, it's you.
Thank you, Didier, for your nice introduction, and welcome to all of you. Good day. I would like also to thank all the co-authors of the paper, Mr. Ferreira from the Americas, Mr. Kaushik from Asia Pacific, Mr. Van Rensburg from South Africa, Dr. Alamedin, our chairman from Switzerland. As you mentioned, Didier, I'm going to describe the importance of synthetic graphite for the major transformations toward a greener world. Then the impact of the green steelmaking and the green mobility on the synthetic graphite industry via the two key products, graphite electrodes, as well as graphite anode powder, made of synthetic graphite. We will then draw the future forecasted picture in a time horizon from 2022 up to 2035. We'll then conclude highlighting the great opportunity that becomes evident as major result of the conducted analysis, as well as the need for significant public initiatives enabling the taking of the opportunity. Two are the disruptive transformations ongoing. The green steel revolution is aimed at reducing the steelmaking's environmental impact towards sustainable practices. It entails replacing coal with hydrogen as the primary reducing agent in steel production using electrical arc furnaces, eliminating carbon dioxide emissions directly from the manufacturing process. The second transformation is the green mobility. It consists in replacing internal combustion engines with cleaner and more sustainable electric powertrains. Synthetic graphite is fundamental for both transformations. Synthetic graphite electrodes are used to melt H2 pre-reduced iron ore. So iron ore reduced by the usage of hydrogen. Synthetic graphite anode are used as negative electrode to power high-performing electrical vehicle, EV, lithium-ion batteries. Let's anticipate some figures that are very important to remember. Synthetic graphite electrode market valued $6 billion in 2022 and will value $10 billion in 2035 with a compound annual growth rate of 5%. While the synthetic graphite anode market valued $12 billion in 2022 and will value an estimated $130 billion in 2035 with a compound annual growth rate of 21%. The key and major raw material for the synthetic graphite used in both graphite electrode and graphite anode is needle coke, which can be produced either from petroleum or coal tar pitch. Higher quality needle coke grades are used to produce graphite electrodes for electrical arc furnace and graphite anodes for batteries. Different grades are available based on key properties, among which I want to mention three: CTE, anisotropy, and sharp edge of crystallite. The CTE, coefficient of thermal expansion, is a key parameter for the graphite electrode production. Anisotropy is key parameter for both of them. Finally, sharp edge of crystallite is a key parameter, basically and mainly for graphite anode. Being a specialty and derived from a byproduct, needle coke exhibits a concentrated supply structure. There are a few major countries producing needle coke globally. And so concerning the capacity, production capacity, 2022, China showed 2,700,000 metric ton capacity, followed far by Japan with 400,000 metric ton, USA 340,000 metric ton, UK 170,000, and South Korea 60,000 metric ton, for a total global capacity, production capacity of needle coke of 3,670,000 metric ton. Here we have to highlight that China wanted to build and built a preemptive capacity just to face and to win over future competition in the world in this sector. Crude steelmaking follows basically three different major routes. Primary steelmaking, so from iron ore through the usage of blast furnaces. Secondary steelmaking, recycling metal scrap through the usage of electrical arc furnaces. And the third and greenest way, the green steel route, using H2 reduced, so hydrogen reduced iron ore in the electrical arc furnaces. Key elements for greener steelmaking are electrical arc furnaces as well as graphite electrodes. Focusing on the crude steel production by region and process, in 2022, we can highlight dynamics and the role of the different players. So globally, in 2022, it was produced crude steel in the amount of 1,883,000,000 metric ton. And of these, almost 1,400, so 1,400,000,000 metric ton were produced through blast furnace, and almost 500 million metric ton through the usage of electrical arc furnaces. By region, we have 80 million metric ton produced in North America by EAF versus 34 million produced by blast furnace. In South America, we have 15 million through EAF and 30 million through blast furnace. In Europe, we had 90 million through EAF and 94 million through blast furnace. In the CIS region, we had 54 million produced through blast furnace and 30 million through EAF. In Middle East, 48 million through EAF and 2 million through blast furnace. In Africa, 18 million through EAF, and 3 million through blast furnace. And then we come to the major producers that were in 2022, China with 925 million metric ton produced through the usage of blast furnaces versus 97 million produced through EAF process route. And then we have Oceania with 2 million through EAF and 4 million through blast furnace, and Asia, excluding China, producing 200 million through blast furnace and 158 million through EAF. So what we can highlight here, and the message is very clear, that the Asian steel production is far the biggest, with almost 73% of the global production. Then the same picture, but showing the percentage of the two processes used. The message is also very clear. The greenest steel production through the usage of electrical arc furnaces is located in the Middle East with 96% of this process used, Africa with 86%, and North America with 70%. While the brownest, let's say, production is in Asia with the 18% through EAF. Based on these figures, so on 2022 crude steel production, I'm going now to describe what was in 2022 the graphite electrode demand and the graphite electrode production capacity by region. So globally, the demand was about 1,400,000 metric ton, and the production total production global production capacity was around 1,500,000, so 1,500,000. From this picture, what comes out very evident is the Asian GE production capacity is far the biggest, with almost 70%, representing almost 70% of the overall production. And it has got the highest excess capacity of 22%. Let's now focus on the key raw material of the graphite electrodes, that is of the synthetic graphite, that is the needle coke. But we need here to explain that the graphite electrode are not made 100% out of needle coke. In reality, the graphite electrode used in EAF, in electrical arc furnaces, are made of 90% of needle coke, while the graphite electrode used in the ladle metallurgical furnaces, LMFs, are made of an average of 15% of needle coke. Using these specific parameters, we estimated that the 2022 global demand of needle coke was around 700,000 metric ton. We want now to outline the future scenario. To do this, we take an estimate of the development of the two main processes for steel making using blast furnaces or electrical arc furnaces. What comes immediately evident that the substitution of the blast furnace way with the green steel way has already started And let's say that based on this estimate, applying all necessary conversion parameter, we come to a compound annual growth rate for needle coke synthetic graphite of 5%, making the projection for 2035 demand to be around 1,300,000 metric tons. After having analyzed the green steel impact, now we switch to green mobility. Electrical vehicles represent the pivot of the green mobility from fossil-fueled towards a more sustainable way to move goods and people. Lithium-ion batteries have become essential for EVs, for electrical vehicles, and predominant type now and at least in the set time horizon. Graphite's role as anode material in lithium-ion batteries has become predominant, driving the demand for graphite material. Graphite anode materials offer exceptional properties, such as high specific energy densities, rapid charging capabilities, and long cycle life, making them superior to other technologies. No technological substitution is expected for graphite anode in the analyzed period of time. Here we see a forecast by IEA organization for the demand, mineral demand of 2050. That is showing a predominance of graphite with 54% versus nickel, 19%, and almost the same percentage for lithium, cobalt, and manganese and lead of 6%, almost 6%. To understand the graphite anode industry, we need to focus on the supply chain behind the green mobility. Therefore, we see the flow from the first trigger of the industry, that is the electrical vehicle market. Afterwards, we focus on the lithium-ion battery industry, then on its major components that are cathodes and anodes. And as already mentioned, the anodes are made of graphite for more than 95%. Finally, on the minerals that are needle coke, silicon, lithium, cobalt, nickel, etc., that are the raw materials of the components. As it regards the electrical vehicles, we can say that green mobility market and production has started in California, USA, in the 90s, but has boomed first in Asia, China mainly, and afterwards a new great boost by Tesla in the Western countries. So in 2022, the production capacity distribution reflected somehow the electrical vehicle market distribution. And Chinese production was far the biggest, representing more than 50% of the overall production capacity. And then followed by 22% in Europe, 12% in USA, in North America, and 11% in Asia, excluding China. Let's now focus on the lithium-ion battery production distribution. Here, the battery cell production capacity is very slowly spreading closer to consumer markets. The actual situation is totally unbalanced, showing 70% of the overall 3,000 gigawatt hour being produced in China, then 20% in Europe, 7% in North America, and 3% in Asia, excluding China. As it regards the cathode production of a lithium-ion battery, then this is also very unbalanced, being produced for 70% in China, and for the remaining, let's say, 30% in Asia, excluding China. As it regards 2022 lithium-ion battery graphite anode production distribution, then it's even more unbalanced, showing of the overall production of 400,000 metric ton, 85% of this being produced in China, and 11 in between Japan and South Korea. So as we did for the needle coke for the graphite electrodes, let us now travel through time to outline the future scenario. And to do so, we take an estimate of the electrical vehicle sales development. So in 2022, more than 10 million electrical vehicles have been sold in the world. And the projection says that in 2035, the number will skyrocket up to 75 million units. Knowing the conversion parameters, I mean the specific weight of the graphite anode in the single battery of the single electrical vehicle, we can outline the following graphite demand projection. The picture shows a booming demand trend from 990,000 metric ton in 2022 up to 6 million and 810,000 metric ton in 2035. We need to describe that there will be a material mix turning, material mix, because for the graphite anode powder, it could be used both natural graphite as well as needle coke based synthetic graphite. Okay, and we see in these projections that the material mix from 40-60 of synthetic graphite versus natural graphite in 2022 will be turning into a 70-30 ratio between the two in 2035. And why this is projected like this? Because the synthetic graphite is more customizable, has got more customizable properties, and it has got a very scalable production process, leading to prefer this kind of raw material versus natural graphite. From a figure point of view, then our forecast is that the synthetic graphite needle coke will then grow demand from graphite anode powder will then go from 400,000 metric ton in 2022 up to 5 million metric ton in 2035 with compound annual growth rate of 21%. Combining the demand of synthetic graphite from the graphite electrode and from the graphite anode, we have a growth rate, combined growth rate of 15%. From 1,100,000 metric ton in 2022 up to 6,300,000 metric ton in 2035. What is immediately evident comparing the demand or matching the demand with the production capacity worldwide is that starting from early 2030s, a shortage in the capacity will show up, reaching 3.4 million metric ton by 2035. But let's describe this trend. So we said that the demand out of both graphite electrodes and graphite anode in 2022 was 1,100,000 and will increase up to 6,300,000 metric ton in 2035. The current production capacity worldwide is 3,700,000 metric ton, almost, and an announced new capacity of 800,000 could be added to this. I mean, comparing and trying to match the demand and the capacity, production capacity, we see that starting from the early 2030s, the gap, also considering an utilization rate of 80%, a gap, an increasing gap between shortage, I would say, between the demand and the actual production capacity. And this gap, this shortage will amount at 3.4 million metric ton in 2035 if eventually no new capacity, additional capacity will be added. Summarizing the results of the analysis, we found imbalances in the needle coke production worldwide, in the graphite electrode production, in the lithium-ion battery cell production, and in the graphite anode production. And the imbalances create a dependency that exposes the industry to geopolitical risks and trade uncertainties. The pandemic, the war in Ukraine, and other global tensions, now the Red Sea crisis, for the second time, have highlighted the vulnerability of global supply chains. The highlighted imbalances make the synthetic graphite industry susceptible to geopolitical disruptions. Imbalances create a dependency that exposes the industry to geopolitical risks and trade uncertainties. The pandemic, the war in Ukraine, and other global tensions these days, the Red Sea crisis, logistical crisis, have highlighted the vulnerability of global supply chains. The highlighted imbalances make the synthetic graphite industry susceptible to geopolitical disruptions. As it regards the shortages, let's remember what happened in 2017, when the 50-year plan by the Chinese government to go for greener industry provoked global shortages of graphite electrodes, and prices skyrocketed to levels never even imagined. Last but not least, China announced in October 2023 curbing exports of graphite as key raw material in electrical vehicle batteries. But this is the past. Looking into the future, as we have shown, projected shortages are forecast in needle coke production capacity, in graphite anode powder production capacity, and in the battery cell production capacity worldwide. On the other hand, we must also highlight the initiatives of many governments to balance the situation of these two industries, so important for the only greener future of the world. USA enacted the CHIPS and Science Acts. Europe and USA introduced trade measures to defend local resources and strategic productions. Governments in Europe have bold public sector initiatives to develop domestic battery supply chains. Last but not least, funds and private investors are investing in these industries. As anticipated at the beginning, let's now repeat and stress the growth figures, so important to understand the opportunity and potentials behind the synthetic graphite sector. Graphite electrode market valued $6 billion in 2022 and will value 10 billion in 35, with a growth rate of 5% annual growth rate. The graphite anode powder market valued $12 billion in 2022 and will value 130 billion in 2035, with a growth rate of 21%. The combination of the two makes the growth rate of the synthetic graphite based on needle coke amounting at 15% annually. These are the conclusion of this paper. Two of the most important disruptive technologies transforming and shaping our societies are the green steel manufacturing and the green mobility. Both are fueling the synthetic graphite demand, graphite electrodes, as well as anode powder, graphite anode powder, with a combined growth rate annual of 15%. Southeast Asia, Japan, South Korea, and especially China, as well anticipated this unprecedented transformation, full readiness and preemptive capacity to cover the world demand for next decade. Likely, new entries are yet to show up: India, Middle East, and Latin America. In contrast with the East, the West, essentially represented by the European Union and USA, is presently well behind in terms of investment and have virtually very little technology grip when it comes to the production of the anode, graphite anode powder. Awakened by the COVID-19 pandemic that uncovered the weakness of the global supply chain and the recent Ukrainian war that exacerbated the pitfall of the dependence of the West on the East, the USA is assertively encouraging initiative through support and grant and safeguard measures in an unprecedented manner. In contrast, the European Union measures compared to USA wake-up call are yet to become more accessible and less complicated. The aim of this paper is to increase awareness for the decision makers in the European Union, public and private, to overcome the above challenges and safeguard strategically the synthetic graphite industry in the European Union. I thank you all for your attention.
Thank you very much, Fabrizio, for this presentation. Very interesting. And yeah, quite, let's say, well documented regarding your forecast. Let's wait if our attendees have some questions. In the meantime, just to let them type their questions, I will start with one question about the strength of your predictions. For the steel industry, which is a major industry, the new technologies are going in the direction of more graphite electrode usage. I mean, DRI, production using hydrogen, etc. increase. So this is pretty clear and mature and not moving very fast. But for electrical vehicles, new batteries technologies are emerging. I mean, sodium batteries, solid-state batteries, and these batteries do not need graphite. Or we have also starting to see some internal combustion engine using hydrogen instead of oil. So regarding all this, how robust are your predictions regarding, let's say, the growth of graphite anodes using graphite anodes market growth?
So first of all, thank you very much for this question. Yes, you are absolutely right. The graphite electrode, let's say, technology is very mature and no substitution is foreseen. While regarding the green mobility, there are a few technologies just now showing up that are announcing or promising some advantages versus lithium-ion batteries. But let's say that in the short term, that means within 5 years from now, the presented predictions are robust. And volume-wise, these predictions are robust also in a little bit longer term time. But let's say that the showed outlook is based on the assumptions that no major technology substitution will occur in the electrical vehicle battery industry. As we can see nowadays, more and more disruptive technologies are developed and affect other existing technologies. For example, the current spread of the use of artificial intelligence. So these are game changers that, of course, could affect other fields, even let's say the electrical vehicle, the green mobility. So let's see, but at least for in the shorter time, I assure that let's say the presented prediction is robust.
Thank you, Fabrizio. I have now one question coming from Italy. Some graphite anode capacities have been announced by several players, but currently not much, let's say, precise things on this. Do you have more precise information on these announcements and graphite anode new capacities?
Let's say that worldwide and outside China, a few graphite electrode producers have got plans and even started to build new production capacity. And they are building them in the surroundings of the existing facilities producing graphite electrodes, because there are definitely some synergies to take advantage of when producing both graphite electrodes and graphite anode powder. The common issue that these companies face is to finance these projects because they are valued hundreds of millions US dollars, as well as to compromise the environmental impact of the new production. As far as I know, current projects are located in Europe, both in the northern, then in the southern Europe, in North America, and even in the Middle East. But no more precise information has been published yet.
Thank you very much, Fabrizio.
Thank you.
I don't have more questions now, so I propose to thank you all our attendees, and thank you again, Fabrizio. And
thank you, Didier.
See you all soon for our next webinar.
Very welcome. Thank you very much. Bye-bye then. Bye-bye.